All right, this is lesson 5.5, and it's the last section of chapter 5. It's been a bit of a long chapter, not as long as chapter 4, but we've had quite a few things going on in chapter 5. And so if you're wondering where it ends, this is where it ends with our double angle identities. And when we did the addition identities for cosine and sine, I just gave them to you, and our focus is on using those identities. For the double angle identities, I'd like to just show you where they came from because they're things you could have figured out on your own as well. So I just like to show that first. And I'll give you these identities, and the focus again will be on using them, but at least show where they came from. Okay, so you guys would know the formula for the sine of a plus b. That goes sine a cosine b plus cosine a sine b. So if we look over here for the sine of 2 theta, I can think of this, and you might think, well, weren't there homework problems like this? And there were. So 2 theta, isn't that the sine of theta plus theta? And so using my identity over here, sine A cosine B, I get sine theta cosine theta plus cosine theta sine theta. And you look at that and realize you just wrote the same thing twice. Sine theta cosine theta sine theta. Multiplication is commutative, so it's really the same thing. So this is really just 2 sine of theta cosine of theta. So you get it's called the double angle identity. What's the sine of 2 theta? And it's 2 sine of theta cosine of theta. And it wouldn't have been a bad idea at the beginning just to ask, do you think when you put a 2 in here, it just doubles the sign? And just like the addition, the answer was no. Do you think you can add up trig functions? You can't add up sines, you can't add up cosines. And so did you think the 2 would just double it? If you did, you were incorrect. So the sine of 2 theta is 2 sine of theta, but you get this other factor tagged along here. So it's 2 sine of theta cosine of theta. Okay, let's do the cosine double angle. And again, you might remember, or you should remember, the cosine of a plus b goes cosine, cosine, minus sine, sine. So let's use that over here, cosine of 2 theta. And I'm 99% sure this was a homework question because I remember people asking it. I think it was 65 on the third assignment. So cosine of theta plus theta, it goes the cosine of A, the cosine of B, minus the sine of A, the sine of B, and then you realize you've just written cosine twice, so that's the cosine squared. You've written the sine twice, and that's the sine squared. So you get this other double angle identity for cosine, which goes cosine squared minus sine squared. So turn the page in your packet, and we've got these identities in here. And so our identities are sine of 2 theta is 2 sine of theta, cosine of theta. We took care of that one. Cosine of 2 theta is cosine squared minus sine squared. And don't confuse that with our other identity. What's cosine squared plus sine squared? That's 1. So the difference is this has a minus sign in it. Okay, this is such a good identity, the cosine of 2 theta, that you could actually write it 2 other ways. So if you don't like the cosine in here, you come back over to this identity and say, wait, isn't cosine squared 1 minus sine squared? Sub that in for cosine squared, and you get 1 minus sine squared minus another sine squared. You get 1 minus 2 sine squared. Or if you don't like the sine squared in here, solve this for sine squared over here, and I get 1 minus cosine squared. Sub that in, and you'll get 2 cosine squared minus 1. So I'm not as concerned that you have the derivations for those two, but we will use at some point all 3 of these identities for the cosine of 2 theta. And then the tangent is the sine over the cosine, and through our identities here and a little bit of division, you could get this identity as well. The tangent of 2 theta is 2 tangent of theta all over 1 minus tangent squared. Okay, so for the identities, if you're looking at this thinking, oh man, more memorization, not so on these. I would like you to know how to use these. You don't need to know these off the top of your head. These will be on your quiz or these will be on your test as they come up. They come up once in a while in calculus. It's nice to know them. But I'd like you right now just to be aware of the fact that there are double angle identities. And if it ever did come up, you'd know to look it up somewhere. Okay, let's practice these. And the homework, when you do the homework, is kind of backwards. And the homework 1 through 4 are going to be the last thing that we cover. And then the rest of the homework will be the thing that we're covering right now. So if you do your homework on section 5.5, let the first 4 problems go and get right on to the ones after that, because that's what we're covering right now. So the question reads something like this. Use an identity, which is what we just did, these double angle identities, to write as a single trig function. So you look at this, you have 2 cosine squared minus 1. You come back to your identities and think, wait, where's 2 cosine squared minus 1? Do you see it? Look, it's right here. 2 cosine squared minus 1. What's the identity? It's the cosine of 2 theta. So I'm just going to write that back on this page. So the cosine of 2 theta is 2 cosine squared minus 1. So I take a look. I've got the 2 cosine squared minus 1. I've got the right side. Take out the right side and put in the left side. So that's going to equal cosine of 2 theta. But look, theta is 25. So 2 times 25. And 2 times 25 is 50. So this is identical to the cosine of 50 degrees. 50 degrees is not on my chart. There's no quick, easy way to do it. So I'll leave my answer just like that. All right, next one. Cosine squared minus sine squared. Come back and look at my identities. Where's cosine squared minus sine squared? Look, right there. It's the same identity. And I'm going to show a little bit of work, but it's possible some of you guys are doing this in your head. So I know the cosine of 2 theta is cosine squared minus sine squared. So I look at it, it's like, oh, I've got the right side. Cosine squared minus sine squared. I'll take that out. I'll put in the left side. It's the cosine of 2 theta, but theta is 15. So 2 times 15 is 30. So it's the cosine of 30. And it happens, 30 is one of my special angles. I know the answer to that. The cosine of 30 is square root of 3 over 2. So I can simplify a little further on that one. Not true on the first one because 50 I didn't know, but 30 I knew, so why not take it that extra step? All right, a couple more of these. 2 sine of 30, cosine of 30. Look back at your identities. Where do you see that one? 2 sine, cosine. Do you see it right here? That's where it's at. Let's write that identity, and again, if you're doing it in your head, even better. But I've got the identity, the sine of 2 theta is 2 sine of theta cosine of theta. I've got the right side. Perfect. Sub in for the left side. The sine of 2 times theta, but theta is 30. So it's the sine of 60 degrees. Guys, remember the sine of 60 degrees? There it is. Root 3 over 2. Next one. 1 minus 2 sine squared. Look back at your identities. Oops, it is not a sine identity. Sorry about that. Cosine of 2 theta is 1 minus 2 sine squared of theta. And again, these identities will be given to you. You just have to know how to use them. That looks like the right side. Sub in the left side. It's the cosine of 2 theta. 2 times 22.5. Do the math on that. That's 45 degrees. Cosine of 45 degrees is the square root of 2 all over 2. Not bad problems at all. All right, let me show you a couple more. I just want to peek here and see what's left here. I've got a couple more. Let's pause this video just for the recording part of it. And in the second video, I'll show you the next 3.